Geometric distribution is used to find the probability given that the following conditions are followed. That is that the data should be have discrete outcomes. It should be divided in two groups. That are success and failure. P represents success, Q represents failure. P and Q should be constants over here. Matlab, the probability of success should remain constant throughout. The probability of failure should remain constant throughout. And because there are only two groups, so the total probability will always be equals to 1. P plus Q will always be equal to 1. Third condition is that events should be independent. Now in geometric distributions, the aim is to find the probability of the first success. For example, if a person is giving a driving test and probability to pass the driving test, let's say probability to pass the driving test is equals to 3 upon 4, and probability to fail the driving test will obviously be 1 over 4, right? Now we have to find the probability, for example, that he passes the test in his third try, right? So to find the probability that he passes the test in the first try, so he has to fail the first two tries and then pass the third try. So in the first try 1 over 4, second try 1 over 4, third try he has to pass, so 3 over 4, right? So this can be written as 1 over 4 square times 3 over 4 power 1. There were total 3 events, right? So I can replace 1 over 4 by Q because it is a probability for failure, right? And the total events were 3, so 2 will be n minus 1, right? Because 2 is 3 minus 1. And then 3 over 4 can be replaced by P because that is the success, and its power is 1. So this is the formula for geometric distributions: Q power n minus 1 times P power 1. So in this example, we were considering that all the events are independent and probability stays constant. So over here, for example, in real life, what would happen was that the person would learn from the first driving test and then have a higher probability in the second test. But over here, we're assuming that the probability remains constant. So through that, we get this formula for geometric distribution. This is the formula for geometric distribution. Now over here, if we list down all the possibilities that the probability of the first success or the second, or for the success in the first try, success in the second try, success in the third try. So in the first try, success probability is P. For the second try, success in the second try, the probability is QP. Then it's Q square P. Basically, we're taking n as 1, 2, and 3. QP and so on. Now if, for example, we have to find the probability of success in less than or equal to nth try, so that means that success could be in the first try, or in the second try, or in the third try, or fourth or fifth, and so on. So it's basically the sum of all of these. Now over here you can see that this is a geometric progression. That is, there's P, then there's QP, then Q square P, then QP. So over here A is P, the first term is P, and the common ratio is Q. So if I use the formula for sum of a geometric progression, so there's A 1 minus R power n upon 1 minus R. A is P, 1 minus R is Q power n upon 1 minus Q. Now we know that P plus Q equals 1. So P equals 1 minus Q, right? So I can cancel out P and 1 minus Q. So the probability of the first success in less than or equals to nth tries is 1 minus Q power n. This is the first formula. Second formula, I mean. Now this was for less than or equal to nth tries. Now if we have to find the probability for x is for success in more than n tries, right? So we'll subtract this from the total probabilities. Total probability is 1 minus q power n, that is q power n. So if we have to find probability of success in less than or equal to n tries, then 1 minus q power n. Probability for success in more than n tries, then q power n. There is the formula for expected value. Expected value in a geometric distribution is equal to 1 upon p, where p is the probability for success. One more thing that I'll mention over here is that to represent a geometric progression, we just need the value of p, that is the probability of success. So we represent it as x follows geometric, and the only parameter is p. So the first question: the probability that a certain sample of radioactive material emits an alpha particle in 1 unit of time is 0.14. In 1 unit of time, no more than 1 alpha particle can be emitted. So from this line we get that there are only two groups. There is either 1 alpha particle being emitted or there are none. So the probability for success, that is an alpha particle being emitted, is 0.14, and the probability for failure is 1 minus 0.14, that will be 0.86, right? So after that, the number of units of time up to and including the first in which an alpha particle is emitted is denoted by t. Now the aim for geometric distribution is to find the probability of the first success. So since over here is talking about the number of units of time up to including the first in which an alpha particle is emitted, this shows that this is going to be a geometric distribution. So I can write that x, or in fact it's t over here. So t is the random variable, follows geometric, and p is 0.14, right? Now they're saying find the value of p, probability of t equals 5. The formula for geometric distribution is q power n minus 1 times p, so 0.86 power 4 times 0.14, so 0.86 power 4, this is 0.0766. Then in part B, probability of t less than 8. So probability of t less than 8. So probability of t less than 8 means that there will be the success is in the first try, second try, third, fourth, fifth, sixth, or seventh, not the 8th. So I can also write this as probability of t less than or equal to 7, because 8 is not included and we're dealing with whole numbers, not there can't be 7.5 tries, right? So probability of t less than or equal to 7, the formula is 1 minus q power n. So 1 minus 0.86 power 7 equals 0.652. Then in the second part, it's asking for the expected value of t. The formula for expected value is 1 upon p. P is 0.14, so 1 upon 0.14, this is equal to 50 upon 7. So the next question 2. Henry makes repeated attempts to light his gas fire. He makes the modeling assumption that the probability that the fire will light on any attempt is 1 over 3. So P equals 1 over 3, and then obviously Q equals 2 upon 3. let x be the number of attempts at lighting the fire up to and including the successful attempt. So over here again we're looking for the first success, so that means that this is going to be a geometric progression. So it will be x follows geo and p is 1 over 3. In the first part they're saying name the distribution of x, stating a further modeling assumption needed. So it's geometric. The reason is that we're looking for the first successful attempt. Then they're saying state a further modeling assumption needed. So we need to, what's the assumption over here? So we're assuming that all the attempts are independent. That means that, for example, in this case, in actual conditions, what would happen is that, for example, you try to light the fire once, then obviously temperature increases, so for the next attempt the probability should increase. But over here we're assuming that probability stays constant throughout, that is 1 over 3. So that's the first part. Now in the second part, find probability of x equals 4. So the formula is q power n minus 1, so 2 over 3 power 3 times 1 over 3. Eight upon 81. Part B, probability of x is less than 4. So x is less than 4 means probability of x is less than or equal to 3, because obviously again we cannot have 3.5 tries or tries in decimals. So probability of x is less than 4 will then be, formula is 1 minus q power n, so q is 2 upon 3 power 3. This is 19 upon 27. In the third part, they're saying state the value of ex, expected value of x. Expected value's formula is 1 upon p, p is 1 over 3, so this will be obviously equal to 3. Now the fourth part is a little tricky. So the fourth part, they're saying Henry has to light the fire once a day starting on March 1st. Calculate the probability that the first day on which fewer attempts than 4 attempts are needed to light the fire is March 3rd. So over here what's happening is that Henry has to light a fire on every day from 1st of March, right? Now the probability we have to find that on March 3rd, it's the first day, March 3rd is the first day when he is able to light the fire in less than 4 attempts, right? So the probability of lighting the fire in less than 4 attempts is successful probability. So successful probability we found in part 2b, that is 19 upon 27, and the failure would be not being able to light in less than 4 attempts, so that would be 1 minus 19 upon 27, that is 8 upon 27, right? Now he has to be able to light it in fewer than 4 attempts on the 3rd day, means we have to find the probability of, let's take another variable, I'm taking y equals 3, right? The formula is q power n minus 1 times p. So 8 upon 27 square times, this is 19 upon 27. So this is 0.0618. I hope it makes sense. Next question, the first part, question 3. Random variable x has the distribution geo 1 over 5. So that means that p equals 1 over 5 and q equals 4 over 5. They're saying find the expected value of x. So expected value is 1 over p, that is 1 over 5 equals 5. Then they're saying find the probability of x equals 4. So the formula is q power n minus 1 times p. So This is 64 upon 625. Then part C, probability of x greater than 4. The formula is, for greater than, the formula is q power n. Q is 4 over 5 power 4. So 4 over 5 power 256 upon 625. That is part 2. They're saying a random variable y has a distribution g of p and q equals 1 minus p. Obviously, show that probability of y is odd is equal to this given. So part 2a, for probability of y is odd, probability of y equals 1 plus probability of y equals 3 plus probability of y equals 5 and so on. Probability of y equals 1 is p, it's basically q power n minus 1 times p, plus q power, this is 3, so q square p, then power 5, so q power 4p, and then so on. Then they're saying use the formula for the sum to infinity of geometric progression to show that py is odd equals 1 over 1 plus q. Now if we consider this a geometric progression, so over here the first term is p and the common ratio will be q square, right? Because q square is being multiplied to each preceding term to get the next term. So if we use the formula for sum to infinity, then the formula is a upon 1 minus r. So p upon 1 minus q square, right? Q we know is 1 minus p. So q square we can replace by 1 minus p whole square. So p upon 1 minus 2p plus p square equals to p upon 1 minus 1 will become 0. So 2p minus p square, 2p minus p square. I can write this as p and then so 2 minus p, if I take p common, right, p and p will get cancelled, right? I can write this as 1 over, it's 2 minus p, so 1 plus 1 minus p. 1 minus p is q, so this will become 1 upon 1 plus q. Question 4. The proportion of people who watch West Street on television is 30%. A market researcher interviews people at random in order to contact viewers of West Street. Each day she has to contact a certain number of viewers of West Street. Near the end of one day, she finds that she needs to contact just one more viewer of West Street. So she just needs one more success, right? So that's why this will be a geometric distribution. Find the probability that the number of further interviews required is 4. So first part, A part, probability that x equals 4. Over here the probability of success is 0.3 and probability of failure is 0.7. So 0.7 cube times 0.3 this is equal to 0.103. Then for part B, probability less than 4, probability of x less than 4, not equals to, just less than 4. So this is equal to probability of x less than or equal to 3. For that the formula is 1 minus q power n, so 0.7 power 3. 1 minus 0.7 power 3 is 0.657. Now in part 2, near the end of another day, she finds that she needs to contact just 2 more viewers of West Street. Find the probability that the number of further interviews required is 5. So still the probability of success is 0.3 and of failure is 0.7. So she has to find the probability that the number of further interviews required to get 2 more viewers is 5. So we have to find the probability of x equals 5. But over here we don't have only one success, we need 2 successes, right? But the last success should be on the 5th try. The first success could be first, second, third or 4th try. So for example, if one possibility would be that on the first try she does not get a viewer, second try she does not get a viewer, third try she does not get a viewer, on the 4th try she gets a viewer, and then on the 5th try she gets a viewer, right? Plus it could be that first, second are failures, then she gets a viewer, then again a failure, and then she gets a viewer. Then there is first is a failure, then she gets a viewer, then 2 failures, and then a success. Then there's first a success, then 3 failures, then a success. So I can write this as 0.7 cube times 0.3 square times 4, because this 0.3 can take 4 places, right? So it's coming 0.123. So this is coming 0.123. Part B. In part B, they're saying that find the probability that the number of further interviewers required is more than 5. So probability x is greater than 5. I can write this as 1 minus probability of x equals 5 minus probability x equals 4 minus probability x equals 3 minus probability x equals 2 minus probability, it can't be 1 because she has to contact 2 more viewers, so she has to interview at least 2 people, right? So 1 minus probability x equals 5 was 0.123. Probability for x equals 4, right? So in x equals 4, there can be first a failure, then another failure, then a success, then a success. So there have to be 2 failures and 2 successes, right? And the first success can have 3 different positions. It could be the first on the first try, on the second try, or the third try. So multiplied by 3. Then minus for px equals 3. For x equals 3, there can be 1 failure and there have to be 2 successes. So 0.7 times 0.3 square. Over here the first success could have 2 positions, either the first or the second, so times 2. Then for px equals 2, there have to be both successes, so 0.3 square. So 1 minus answer. So this is coming equal to 0.528. So this is question 5, I guess. Now the first part, a clock is designed to chime once each hour on the hour. The clock has a fault so that each time it is supposed to chime, there is a constant probability of 1 upon 10, 0.1, that it will not chime. It may be assumed that the clock never stops and the fault occurs independently. The clock is started at 5 minutes past midnight on a certain day. Find the probability that the first time it does not chime is 6 on that day. So the clock is okay. So over here we have to find the probability that the first time it does not chime, right? So the success is that it does not chime, that is 1 over 10 or 0.1. The failure would be 9 upon 10. And because again we're looking for the first time, the first success, so it's going to be a geometric distribution. Now in the first part they're saying it first does not chime at 0600, right? So it starts at 12 or it starts basically at 0005, right? Then it should chime at 0100, then at 0200, then at 0300, because it has to chime at each hour, then 0400, 0500, and then 0600 it does not chime. So it does chime once, twice, thrice, 4, 5. 5 times it does, 1 time it does not, right? So the probability for x equals, it has to not chime on the 6th attempt, so we'll have the probability as 0.9 power 5 times 0.1. So 0.059. Next, they're saying that it does not chime before 0600. So we have to find the probability that x is less than 6. This is equal to the probability that x is less than or equal to 5. That is 1 minus 0.9 power 5. That is equals to 0.4095. Now part 2. So they're saying another clock is designed to chime twice each hour on the hour and at 30 minutes past the hour. This clock has a fault so that each time it is supposed to chime, there is a constant probability of 1/20 that it will not chime. It may be assumed that the clock never stops and the faults occur independently. The clock is started at 5 minutes past midnight on a certain day. Find the probability that the first time it does not chime is at either 0030 or 0130 on that day. So it has to chime twice each hour. That means that at half past the hour and at the hour mark. So it starts at 5 minutes past midnight. That means it starts at 0005. Now it has to chime, it has to not chime at 0030. That means at the first attempt. So probability of x equals 1, or let's take it as y over here, second part, plus, it's saying or 130. So 130 would be the third attempt, right? Because the first is at 0030, then at 0100, then at 0130. So it's the third attempt, so p y equals 3. So probability of y equals 1 will be, over here probability of success is 1/20, right? P equals 1/20 and Q equals 19/20. So for this, probability of y equals 1 will be 19/20 power 0 times 1/20 plus 19/20 squared times 1/20. So 1/20 this is equal to 0.0951. Now part B. So saying use the formula for the sum to infinity of a geometric progression to find the probability that the first time it does not chime is at 30 minutes past some hour. Okay, so 30 minutes past some hour means that it does not chime at, for example, at the first attempt, that is at 0030, or at the third attempt, that is 0130, or at the fifth attempt, that is 0230, and so on. So for this, the probability would be 1/20, plus for the second one it would be 19/20 squared times 1/20, then 19/20 power 3 times 1/20, power 4, sorry, and then so on. So over here, the first term, if we take it as geometric progression, the first term is 1 over 20, and the common ratio is 19 over 20 whole squared. So we have to find the probability that it does not chime at 30 minutes past some hour, right? So we have to basically find the sum to infinity of this expression. The formula for sum to infinity is a upon 1 minus r. A over here is 1 over 20, so 1 over 20, r is 19 over 20 whole squared, so 19 over 20 squared. This is coming equals to 0.513. I hope it makes sense. Question 6. Sandra makes repeated independent attempts to hit a target. On each attempt, the probability that she succeeds is 0.1. So P equals 0.1, Q equals 0.9. Find the probability that the first time she succeeds. It is the first time again over here. So for that, it will be a geometric distribution. So now part 1, part A. Find the probability that the first time succeeds in order 15 on her fifth attempt. Px equals 5. The formula will be 0.9 power 4 times 0.1. That is equal to 0.0656. Then part B, the first time she succeeds is after her fifth attempt, right? So probability of x greater than 5, that is 1. Sorry, the formula for that is q power n, so 0.9 power 5. This is equal to 0.590559. Then in the third, in part C, they're saying the second time, the find probability that the second time succeeds is before her fourth attempt. So this is a little tricky. Now over here, she has to succeed twice, right, before her fourth attempt. So she has to succeed twice in 2 or 3 attempts, right? Because it can't be one attempt. She can't succeed twice in one attempt. She has to succeed twice in 2 or 3 attempts. Now to succeed twice in 2 attempts, she has to succeed in the first attempt and the second attempt. To succeed in 3 attempts, she can maybe succeed in the first attempt, not succeed in the second attempt, and then succeed in the third attempt. Or she can succeed in, she might not succeed in the first attempt, and she succeeds in the next 2 events. We can't have 0.9 at the end because the last one has to be a success. Because if we had 0.9 over here, then we'd just stop at 2 attempts. We wouldn't go to the third attempt. That's in this case, right? So the answer would be .028. The second part. So Jill also makes repeated attempts to hit the target. Each attempt of either Jill or Sandra is independent. Each time that Jill attempts to hit the target, the probability that she succeeds is 0.2. Sandra and Jill take turns attempting to hit the target, with Sandra going first. Sandra starts. Find the probability that the first person to hit the target is Sandra on her second attempt. So first Sandra tries, but Sandra fails in her first attempt. Then Jill tries and Jill fails. Then in Sandra's second attempt, she does not fail, right? So the probability for this, for Sandra to fail in the first attempt, Sandra's probability to fail is 0.9, right? So because this is the probability to succeed. So Sandra to fail in the first attempt is 0.9. Then for Jill to fail in the first attempt is 0.8. and then for Sandra to succeed in the second attempt is 0.1. Find the probability that the first person to hit the target is Sandra on her 10th attempt. Now it's their 10th attempt, so she fails in her first attempt, then Jill also fails in her first attempt, then Sandra fails in her second attempt, Jill fails in her second attempt, Sandra fails, Jill fails, Sandra fails, Jill fails, Sandra fails, Jill fails. So like this, there will be 9 times that Sandra fails and 9 times that Jill fails, and then in her 10th attempt Sandra will succeed, right? So Sandra has to fail 9 times, so 0.9 power 9. Jill has to fail 9 times, so 0.8 power 9. This is 0.8, and then Sandra has to succeed in her 10th attempt. So it's coming equal to 5.2 times 10 power negative 3, that is equal to 0.0052. This is the last question for the video. Now, because for geometric progression, as it is a new topic in the S1 syllabus, so there aren't many questions from the past papers, so I'll be adding the link to a PDF from which I took these questions, so you can attempt the rest of the questions from there.